Welcome to FIT's Machine Shop. We are here to not only help you build your projects, but really our number one concern is your safety, to make sure that you're using the equipment properly. Whether you're doing this as a refresher or you're going for recertification, if you're not sure about how to use any piece of equipment, any tool, please just ask us. We're here and we're willing to help. Okay, as soon as you walk into the shop, you are now adhering to shop rules. Rule number one is you have to have your proper shoes and safety glasses. They go on immediately, they're right hanging on the wall. I also choose to use earplugs. There's no horseplay. There's no talking on the phone. We are totally focused on what we're doing and paying attention to the equipment when we're using them. And any questions, again, just ask any of us. Before operating any piece of equipment, equipment moves, spindles turn. Our long hair is tied up, our sleeves are rolled up or tied tight, shirts tucked in, no big necklaces hanging out. Safety is number one concern. Next thing you do when you come into the shop, you come over and you scan your student ID card. Swipe your card. It will print out a label. It will only print out a label if you're certified and if your certification is current. Your label has to be placed somewhere on your body that is visible to us. That way when we scan the room, we see everybody's labels and we know that everyone's certified that's operating equipment. If your certification is not current, you have to come see us and you'll sign up for a recertification class. Recertification requires you watch a video, a safety video. We go over the shop rules and you take a test.
Welcome students to our Florida Tech YouTube video presentation. This is our vertical milling machine. What I'm going to do is refresh how we approach the machine when we're starting to work, because there's been some problems in terms of how to put the tools in, take the tools out, and various other elements. So we have a part, we need to mill it square. So the first thing we want to do is set the machine up to mill this surface here. So we see we have a drill chuck in here. This brings up an important point, is we do not put drill bits into collets. We only put drill bits into the drill chucks. So if you're going to use the milling machine to drill holes, we need to put a drill chuck into the machine. But right now we want to put a milling cutter into the machine, so we need to take our drill chuck out. So we take our 3/4 inch wrench, we put it up on top of the drawbar because we have to unscrew our drawbar to release the drill chuck. We put on the brake, release the drawbar about a half a turn only. Then often you can just take and tap the drawbar with a wrench and it'll come out. Other times it won't come out and you have to use a nice brass hammer. This time it came out quite easily. You unscrew the drawbar and take the drill chuck out. So let me show you what the drawbar is. This is actually the drawbar that runs down through the spindle, and this is actually a collet. So what we're doing is we're putting our cutter, whatever type of cutter or drill chuck, into the collet, inserting the drawbar, and then when this tightens, it pulls up against the taper here, which locks the cutter or the drill chuck into the machine. So when we go to take it out, we unscrew the drawbar just a little bit and then tap it. One thing that's been happening, and we lost 3 drawbars last year in 1 week, is the students will unscrew the drawbar completely from the collet, then take the brass hammer and pound it. What happens if that happens is it rolls the first threads of the drawbar and pretty much ruins it. So the correct way is to unscrew only a half a turn. If you have to whack it with a brass hammer, you can give it a really good pop, or 2 or 3 or whatever it takes to release the taper onto the collet, and you do not injure the drawbar because there's enough threads engaged that it won't get mutilated. So now we want to put our end mill into the machine because we're going to mill the corner of the plate. We insert like this, reach up here to the drawbar, and screw it down into the collet. At this point, we take then our wrench again, put our hand on the brake, wrench at the top of the drawbar, and we tighten it. And all we have to do is just firm it up. Twice, students have tightened it so tight that I had to go get a pipe and put it on top of here and push while he held the brake to unscrew it. Doesn't need to be that tight. The next thing we do, we need to know how to turn the machine on. This switch has a high and a low. Depending upon which you go to, high or low, is depending upon the rotation of the cutter. So I'm going to switch it one way. Notice that the cutter goes in the correct direction, which is a clockwise direction as you're looking down. The switch has two positions like I mentioned. If I turn it into a low, it's going to turn backwards. This is part of our machine shop training, and it's called awareness. This is a real Zen type environment. Zen being that if your thoughts are going 100 miles an hour and you're thinking about this and that and the other, then those block your attention. We have to shift our attention from thoughts to being here, present, now, Zen. So, first thing you do when you turn on a machine is you watch which way it cuts. If it's turning counterclockwise, we got a problem. The problem is it won't cut. It destroys the part, destroys the cutter. So that's $30 down the drain. And this happens quite often. The other thing is, when we do use our cutter, we use our cutting fluid. It's very much like, it's a soluble oil, very much like dish soap. That keeps the aluminum or steel from gumming up and ruining the tool. Okay, one of the things that happens when a student turns it on backwards is he says, well, this is a stupid machine. It's got two positions. It's got a high and a low. Why doesn't it turn on just like my fan? It only goes on in the right directions. Well, there's a reason for that, and it's not a stupid machine. It has what's called a back gear. This is the back gear. What happens is it's in high range now. If you push this knob in, move it towards the back, then you turn the machine on to low, it's going to turn in the correct clockwise position, but much slower. So we have a back gear for turning really slow, drilling really big holes, cutting really hard material. Then we have the forward position, high. Notice that when I move this over here, it didn't go all the way. You must grab the spindle, give it a shake, and then it will pop into your high range. If you don't do that and turn the machine on, it'll make the loudest, ugliest noise you ever heard in your life and be very embarrassing. So, okay. Right direction. It's still maybe going too fast. This machine is variable speed. So we turn it on. We can slow the speed down or speed it up with the variable speed knob. Speed is very important. That comes to another situation, is we as students don't always know the correct speeds and feeds and whatever to use. So that's when you come up to me or Anthony or Bill and say, gee, I'm not really sure. We'll step in, we'll help you out. The last important point that I want to address is the difference in the way you can mill a part. If this cutter's turning clockwise and we come across this edge here, then that is conventional milling. So the part actually progresses into the edge of the cutter. That's the safe way to use these manual milling machines. If we go in the opposite direction, it's called climb milling. That's where the milling cutter is going also in this direction, but we're actually climbing on top of the edge. That's not safe on these machines. The reason why it's not safe is that the tables are very, very loose and they can shake. And then what will happen is as it climbs onto the part, it'll grab a hold of the machine and pull it into it. At that point, it can break your part, break the cutter, and cause some problems. The one last thing I want to mention is if you're milling in this direction, there is a lock, a table lock on this side that you can put on to keep the table from drifting as you're milling across it. If you're milling in this direction, you can use a table lock here for the X that'll prevent the table from moving this way. That's about it for the vertical milling machine. This is the engine lathe. This handle moves it back and forth this way. This handle moves it this way. One of the problems we have in the past is turning the machine on. This handle turns it on and it rotates in this direction. We can also pull it upward and it'll rotate in the opposite direction. This is the way we do not want it to be turned on. If we do this, and we've had students do this, it ruins their parts, it makes a mess. It's hard on the machine. The cutters are like this. They mount in the tool post, and the rotating part comes down against the cutter, so it needs to rotate in the correct direction. I've labeled this tool post sharp to be for the sharp machine. You put it in the tool post, clamp it down, and the reason why it says sharp and it's labeled for this machine is the tool is right at the center line of the part. So the tools, whatever tools you use, need to be set at the center line of the part. This is a form tool. Does the same thing, puts a nice 45-degree chamfer on your part. This tool is a normal turning tool. It will face off and also turn your outside diameter. Provides two separate functions. One of the things that I've installed in this shop 2 summers ago is a travel indicator. What we'll use the travel indicator for is so we can bump up against our face. This is the face of the part. We can zero our travel indicator. And then we say we want to come back 500 thousandths and turn a shoulder here. So we can take our travel indicator and go 1, 2, 3, 4, and 500 thousandths. That's where we want the machine to stop when we made a cut. So we can readjust our travel indicator to not tell us a dimension, but to tell us where to stop. And this is very unique. This is a unique way of doing this that works quite well. So we take it to where it only makes less than 1 revolution, and we zero it. So as the machine is progressing across the part, turning our outside diameter, we can stop the travel at 80 or 90 thousandths and then hand feed it to 0, so that we're coming up against an established dimension.
Okay, I hope this has been a good learning experience for everybody. I hope that you've understood everything. Again, any questions, please come to any one of us and ask. We want this to be a safe environment and make sure that your projects are done the way you want them to be done, but that safety is the #1 concern. Thank you and good luck.